This number 5 is on here just for a couple of reasons. One of which being, again, just multiplying probabilities here. Right? If you're rolling 3 dice and you want to know what's the chance you're going to get a 5 on all 3 of them, you can multiply the individual probabilities, right? Especially since, in this case, what happens on one die is independent of what happens on the other ones. So if you want this probability of all 3, 5s, chance of a 5 on the first dice times chance of a 5. I guess we could use the word, or it looks weird. Okay, chance of a 5 times chance of a 5 times itself 3 times, right? I don't care if you use the symbols here or not, but in other words, a 1 in 6 chance, 1 in 6 chance, 1 in 6 chance. You're multiplying those 3. Or of course you could write it as a 6 to the 3rd power. 1 out of 216. If you made some kind of way of showing the sample space, there's only 1 out of all 216 outcomes that you're getting 3 5s. The reason I asked this is to have you think about the different possibilities when you have something like at least one 5. There's a lot of different cases here to think about. You could get no 5s. You could get 1 5. You could get 2 5s. Or you could get all 3 5s. We just worked out this one, right? This is this. I don't know why I put an N on the end of there. 1 out of 216. That's what that is, right? 2 5s, there's more than one way it can happen. There's only one way you can get all 3 5s, right? You can get a 5, then a 5, then a 5. But the other ones, there's different orders that can happen. So for this one, you can't just say the chance of getting 2 5s is 1 6 times 1 6 times, well, the other one has to not be a 5. It's that. That's the chance is going to happen in that order. Like the 3rd dice is going to be a non-5. There's actually 2 other ways, right? You need this one. The second one is the non-5. Or you need the first one as the non-5. There's 3 different ways that can happen. You need to include them all. They're all going to be the same. So if you wanted a shortcut for that, you could say it's 3 ways, and it's, a 6th times a 6th times 5 6, and just multiply it by 3 if you want. And the same thing goes for this, right? 1 5, you have a 6 times 5 6 times 5 6. But then there's the other ways as well, right? This is a lot of different cases, right? This is too many to add up. 5 6, 5 6, 1 6. There's seven different cases there, right? There's one way you can get all 3 5s. There's 3 different ways you can get 1 5 or 2 5s. But there's only one way this can happen, no 5s. And this is the complement. The reason I put the word complement in there is because if you're interested in knowing what all of this adds up to, right? Because we could figure out what it all adds up to. If you did it the long way, which maybe I should have had you do it the long way first. If you we already worked out that's 1 out of 16, or 216. This is 5. This thing is 5 out of 216. 5 out of 216. This is 5 out of 216. Whoops. And then each of these are 25 out of 216. If I move all of this stuff over. Get some of this out of here first. Okay, each of those other ones is 25 out of 216. This one, 25 out of 216, 25 out of 216. You could add all of that together, right? There's all 7 of those different cases. What does that add up to? We got 75, 85, 91. 91 is what you should end up with here. 91 out of 216. That's if you add up all 7 cases, but the quick way to do that is if you recognize that there's only one case in the complement. Okay? The complement is just one case. Okay, the complement, oops. The complement has only one case. no 5s. If you work out the chance of getting no 5s, you can subtract it from the total, right? The chance of getting no 5s is chance of not getting a 5, not getting a 5, not getting a 5. That's the only way it can happen, all three non-5s. 5, 6, 5, 6, 5, 6. If you work out, and I should do this down below because it's becoming a mess up here. If you work out the chance for that, okay, the chance of getting no 5s at all, that's a lot quicker and easier. That gives you, what does that give you? 5, 6 times 5, 6 times 5, 6. 125 out of 216. This is the chance of no 5s. The chance of at least one 5. You can find that by subtracting that from the total. You can say that this is 1 minus, or 100% minus 125 out of what we just found here. 125 out of 216. Or in other words, 216 out of 216 minus 125. That's going to leave you with the leftovers here. That's 91 out of 216. You should understand how you can use the complement. No one's saying you have to use the complement, but that's something that's part of the reason I put that question in there, is for you to realize that sometimes it's easier to find this. Okay? One of the typical questions that people ask for this concept is, what's a chance that at least 2 people in this room have the same birthday? Well, there's a lot of cases of that, right? It could be these 2 or those 2 or these 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 2. The easier way is to calculate the chance that nobody has the same birthday and subtract. We're not going to do this question. It's very involved. But it's a way of, it's a much easier thing to do to calculate the chance that no one has the same birthday than calculate for every single case that you match up. I know you're just telling me 2 people have the same birthday. Cool. The chance is actually pretty good if you have 30 people that at least 2 people do. It seems like it wouldn't be, but it's pretty good. Anyways, that's related events with and. We're going to look at this next.